Everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Gorowski, and I'll be your host for today. If you're just tuning in for the first time this month, we have a jam-packed month of live events for classrooms to join us from all across North America and beyond. If you visit exploringbytheseat.com, you can find all the events that we have coming up and how to register and join with your classrooms. All right, well, let's get to the main event today. We always love when we have an opportunity to head out into the field. And today we're heading live on board the research vessel Revelle, where a team of scientists and engineers from Woods Hole Oceanographic Institution and Harvard University are exploring the hydrothermal vent sites within the Guaymas Basin. So we're going to be joined by Dr. Anna Michel, who is an ocean engineer and is the chief scientist of the cruise. We'll also be joined by engineers who design and operate the deep diving robots, the AUV Sentry and the ROV Jason. So I'm going to bring Anna in here with me right now. Hey, Anna, how are we doing today?
We're great. How are you, Joe?
Good, good. Well, it's great to be connecting live from the Pacific. We're so excited for the live event today. Anna, why don't you start off by telling us a little bit about, who's joining you today and just what you've been up to the last little while.
Yeah, it's great. So we're in the Gulf of California at a site called Guaymas Basin. I'm here right now next to Genevieve, who is a graduate student in the MIT HUI joint program. She'll be telling us a little bit about what she's doing on this cruise. And we'll be showing you some live video of the hydrothermal vents that we are working at. You'll get to see some great imagery of some tube worms and some chimneys. And then we'll be introducing you to some of the Jason ROV team and also some of the Sentry team that's using an autonomous underwater vehicle to do some mapping of the area.
All right, that sounds great. We're really excited. Why don't we start off by meeting a few engineers, and then we'll bring in that live feed because it is so cool.
And do you have the live stream showing from the underwater?
I do. Let me pop it in right now. There we go. This is coming in live from the Jason van, where we have the team, the navigators, the ROV pilots, giving us a little live view. In fact, Jason Van, if you're able to hear us, why don't you tell us a little bit about what we're seeing right now?
Hi, folks. Can you hear me okay?
Can you guys? Yep, we can hear you, Pete.
Yep, coming through.
Hi, thanks. My name is Pete Gerges. I'm one of Dr. Michel's colleagues, and I'm on watch here in the Jason van. We are now looking at a hydrothermal vent, and you're looking at a chimney, and that's our nickname for these structures. They kind of are tall, and they come in different sizes, and they're actually made of metal sulfides. A good example of a metal sulfide is fool's gold or pyrite. And so this stuff is made of a bunch of metal sulfides, and a lot of animals like to live on them. So the big red animals you're seeing are Riftia tube worms. They're one of the fastest growing animals on the planet. And what's really cool is they grow crazy fast without a mouth or a gut or a digestive tract. They do it by culturing bacteria deep inside their bodies that they feed chemicals, and the bacteria in turn feed the worm. One of my favorite things about this kind of work is I get to work with amazing ROV pilots and group leaders. There are two people who want to say hi quickly, including Michel and Corey. You guys want to chime in?
Hey everybody, this is Michel. I'm a Jason pilot, and while I'm not driving at the moment, Corey's doing the driving, but he's just manually spiraling around the chimney and collecting some nice video for a photo mosaic.
Hello, my name is Corey. Currently driving the robot. Actually, we just passed something super cool that I don't get to see a whole lot. It's something called a flange, which I can't exactly explain, but it's beautiful. Pete can tell you all about it if you want.
Like I said, my favorite thing here is getting to work with a team of people, because we all have our own little bit of expertise. And Michel and Corey have done a lot more work and dives at hydrothermal vents than I ever will. And so they're masters at sort of flying around and getting the video we want. And that thing Corey was talking about, which I'm sorry we can't really see right now, but something neat happens on these chimneys where hot water kind of pools in an upside down bowl. So just imagine a bowl that's upside down sticking out the side of this thing. And if you look at it carefully, it's like looking at a mirror. So they're really, really beautiful. Hopefully you'll get to see some maybe later on if we get there. So thank you very much for your time.
All right, very cool. What a great view. I'm going to keep that up there so we can keep watching what we're seeing. But thanks so much for the team in the van for sharing that with us. I'm going to bring back in our topside team. Anna, if you want to pop back in, let's find out a little bit more about what's been going on the ship.
Great. So I have with me Genevieve, who's a graduate student, and she's going to tell you a little bit about what she's doing with one of the underwater robots.
Yeah, hi all. So my name is Genevieve. I am a roboticist and a computer scientist, and I'm a PhD student at MIT in Woods Hole. And so my job for the cruise is to build an autonomous underwater vehicle and help that vehicle find hydrothermal vents in the ocean. So you guys have probably heard of autonomous cars or autonomous vehicles, where we have a vehicle that can drive by itself and do the things you want on the road in a car. Underwater, we have the same thing. So we have these robots, these big robots that we put underwater, and we want to give them a brain so that they can explore the ocean and find us those hydrothermal vents that you just saw. So here on my computer, I'm building all of the code and doing the programming that we need to put a brain in that vehicle so it can sniff out hydrothermal vents. Each vehicle has a little chemical sensor on it that allows it to detect when it's found plume water. And then we put all of that together to try to build a map of what we're sensing under the ocean. So this is the path that we planned for the robot. It's flying in what we call a lawnmower, which is this big path where it goes back and forth, sniffing out that sign of a chemical plume. And whenever it detects the plume, we mark that with a color. And so you can see here that we're getting this big kind of plume detection region over here, where the robot is able to tell that there's a hydrothermal plume, and then we send it back to drive there so that we can get the video and collect biological samples and do our science. So I think being part of this cruise has been amazing as a computer scientist and a roboticist to try to make the robots smarter and more intelligent so that we can find these plumes quickly and do ocean science more efficiently.
So I'm going to walk you over. We're going to meet some of the Sentry AUV team members. You can see them working hard over here. And in just a minute, we'll be able to learn what they're actually doing. Let's see, we're going to step over here and learn about one of the instruments, and we'll come back because they're in the middle of some operations. This is another graduate student. This is Beckett Coulson. Beckett, can you show us your instrument that you're working on for underwater studies?
Sure, yeah. So I'm Beckett. I'm a PhD student like Genevieve in Anna Michel's group. And I work on developing sensors. So this here is a deep sea laser spectrometer designed to measure carbon dioxide. So it helps us understand things like ocean acidification, carbon cycling, and sort of how that biological cycle balances out. So this actually makes measurements of dissolved gas by pulling dissolved gas through a membrane inlet and feeding it inside of the instrument. And so one of the cool parts is there's this optical cell here, which bounces the light of a laser around in a star pattern and lets us measure how much CO2 there is. It's been really cool to be out here on this cruise, getting to test something that I've built on real deep sea vehicles.
Great, thank you, Beckett. Let's see if we can get a couple words out of the Sentry team. Here's some of our Sentry team right now. We've got Justin Fuji and Amanda Sutherland. Amanda, can you tell us a little bit about what you're doing?
So this is the Sentry watch station. So Sentry is in the water right now on a dive. This little orange blob that you see here is Sentry. These are plumes that are going over. This track here is where we just came from. All these lines show the pattern that we have been running and that we will continue to run over this area. So yeah, I'm just making sure Sentry is an autonomous vehicle, so it does whatever we tell it to do when we program it in before it goes down. So I'm really just watching right now just to make sure that it's doing what it's supposed to be doing.
Amanda, can you tell us how long Sentry's been down and how long will it stay underwater?
It went down at around about 11 p.m. last night, our time, which was 7 UTC, and don't know what that is in any of your time, I'm sorry. And it will probably be coming out tonight at around about the same time, so about 11-ish, so about a 24-hour dive. Yeah.
And I mean, can you tell us how you became an underwater roboticist?
So I went to engineering school and I did mechanical things and also some software stuff as well. So college for that, and then I got an internship at a place that did underwater stuff. And when I was in college, so my last summer before I left college, and that was really cool. I thought it was something I wanted to do afterward, and then I got a job at that place, and then I decided that I really wanted to do things that were more alongside scientists, and we is the perfect place for that. So that's how I ended up here.
Great, thanks, Amanda.
Thank you. If there are any questions, let me know.
All right, Joe, that's who we've got down here. If you want, do you want to go up to the Jason van and hear from some of the group up there, or do you want to go to questions?
Yeah, let's head up to the Jason van. We'll save our questions. We'll do a few more towards the end. Let's head up to the van. And while you're making your way there, I'm going to pop up our view from Jason.
So I think we're going to keep the video off up there. I can go up there if you prefer, or we can just turn on their audio and they can talk from up there. Sarah, could you turn the audio on the Jason van, and could you have a few of the people in the van introduce themselves and tell us what they're doing?
Sure. Hi, everyone. I'm Sarah. I know you can't see us, but I'm a research assistant in Anna Michel's lab. I'm up here on watch in the Jason van with a team of scientists, students, and then members of the Jason team. So you heard from Michel and Corey before. Corey's currently driving Jason, just kind of circling those tube worms that Pete explained before. So we have some students here, so I'll have them introduce themselves and kind of explain their role of what they're doing on the cruise.
Hi everyone, I'm Don Marticello. I'm a graduate student in the Woods Hole Oceanographic Joint Program in Chemistry. I'm actually studying stuff, so you're looking at the chimney right now, and so about a couple hundred meters up you have this thing called a plume. And that's where you have a lot of the fluid that's coming out of here mixing with seawater, and at that interface there's really cool microbial reactions, and that's where my PhD work is, studying a lot of that stuff, and happy to answer more questions if people are interested in that.
Hi, everyone. I'm Brooke Travis. I am a first-year graduate student in Pete Gergis's lab at Harvard University, and I'm on this cruise to begin my PhD experience by learning about, what it takes to be on a cruise and the role of things, and to also do a little bit of research on the tube worms you see presently in front of you. We're interested in kind of looking at rates of their reverse citric acid cycle and citric acid cycle and comparing those things.
Hey everyone, I'm Jason Caput. I'm an engineer at the Woods Hole Oceanographic Institution. My role here is helping develop a number of the chemical sensors we're using on board here to learn about the environment around these chimneys and vents and sites. One thing that I really like, so what we're actually measuring with these sensors is a dissolved gas, methane, which some of you may have heard of. It's important for climate reasons. It also influences the biogeochemistry of these sites. We also have sensors that measure carbon dioxide in these areas. And one of the things I really like about this work is these sensors measure things that you can often not smell or see or hear or taste. So it's like developing a new set of eyes or a nose to detect what's in these areas and how much. Yeah.
Hi guys, my name is Osama Alian. I'm a fifth-year PhD student at Michigan State with Dr. Matt Schrenk, working with Dr. Pete Gergis here as well, our very good friend. And I'm actually in the microbiology aspect. I'm interested in a lot of these microbes that grow on the outside of these chimneys. You can kind of see them in this live stream. They're multicolored, but also some of the microbes that can be growing inside. And I'm really interested in defining the dynamics of their evolutionary history, because these chimneys form partly from a chemical process, but they could also grow and change depending on what the microbes are doing inside. And that information will help us sort of define how microbes survive in these extreme environments. And we could take that a more exciting step further and really develop a model of how in other worlds off of Earth that these hydrothermal systems can be functional on. What should we look for in terms of microbial activity or biological traces or cool metabolic processes that enable them to survive in these really weird, exotic, beautiful places?
Hello, everyone. My name is Sebastian Kraus. I am a sixth-year PhD student from the University of California, Los Angeles, and I am a guest scientist that was invited by Pete Gurgis and Michel and Scott Winkle, and I'm working with Dr. Tina Troyer at UCLA. My role on the ship is, besides having a helping hand, I'm also focused on a lot of geochemical analysis for the plume waters and also sediment and pore water geochemistry, which we will be collecting later on in the cruise. But yeah, happy to answer more questions later on and leave it to the rest for the rest of it.
Cool. So that is all of the scientists in the Jason van right now, and then also Kel and Corey, which you guys met before. I know that's a lot of information, but it kind of just highlights the awesome interdisciplinary research going on here. It really brings together the scientists, engineers, and the ship crew to make it all happen.
All right, very cool. So I was noticing as we were kind of going around the chimney, it looked like little white crustaceans on the side. What were we seeing there?
Hi, folks. This is Pete again. The white crustaceans are called squat lobsters, and they're crabs that like to live around hydrothermal vents. At some of the other vents, there are other white crustaceans that are a little bigger. They look more like a crab you might get for dinner somewhere. We don't have them here. I wish we did, because they love to try to take little snips of the tube worm tubes off. They just sit there and they pluck at the little red feathery plumes. But these little ones don't do that. They just eat the microbes that are growing on the rocks. It's a great question.
All right. And one more question before we start bringing some classrooms in. What depth is Jason at right now?
Jason is currently at 1,800 meters.
All right. Very cool. Well, if you're tuning in live via YouTube, you can use that live chat to send us in some questions. I'm going to start bringing in a few camera classrooms as well and give them a chance to ask some questions live to the team. So let's see, where should we go first? Mr. Brooks' crew is joining us. They're fifth graders in New Jersey. I'm going to bring him into the call right now. Hey, Mr. Brooks, how we doing?
Hi, how you guys doing? Everybody wants to say hi.
Hey, fifth graders, how are you?
We think it's amazing what you guys are doing, and everybody's so interested. We're like here speechless. So
very cool.
What did you want to ask?
There was like a big green thing on the side. What is that?
So when you were circling around, you just asked about the tiny white crustaceans. There was kind of a bigger one that was green. What do we know what that was?
Sarah, can you guys answer that from the Jason van?
Yeah, so the green crustacean looking thing was an anemone. I don't think it's on film right now anymore.
We'll probably work our way back there, folks.
All right, very cool. We'll keep an eye out for that. And Mr. Brooks, I'll come back to your crew in a little bit, and we'll steal another question. Okay, so I'm going to pop over to another classroom this time. We're going to head to Canada. We've got Miss Rob's crew joining us from Ottawa, Ontario. I'm going to bring them into the call here. Hey, Ottawa, how we doing?
Hello, can you see us?
It's the screen is black, unfortunately. I can see it on the smaller screen, but no worries. If we can hear you, we'd love to grab a question.
Awesome. Heston has a question.
How long are you guys usually underwater for?
How long are you usually underwater for? And can we also add to that, where are you underwater at the moment, please?
So those are great questions that I can answer. So we have 2 vehicles or 2 robots out right now. We have the Jason robot, which is what you're seeing the video from. And that can stay down for several days. We'll probably be down for about 24 hours on this dive. We also have Sentry, which is an AUV that's out diving right now. And that one will leave down for probably about 20 hours on this mission. We are actually at Guaymas Basin, which is in the Gulf of California. So after we're done with the live stream, if you pull up a map and you kind of look at the map of Mexico, you can look where the Gulf of California is. And we're tucked up quite far up into the Gulf of California.
All right. Very cool. Thanks for those great questions. We'll come back your way shortly. I'm going to grab one here from YouTube. This is specifically for Brooke. Brooke, if this is your first cruise, what has surprised you so far?
Yeah, so this has been a really great experience. I think what has surprised me so far is how amazing everybody is. The team here is just really great at working together to get what we need to get done. And I'm, surrounded by incredible scientists and engineers, and I am so surprised by how much I'm learning just so quickly, just by being around in this environment. So I'm really happy to be here.
All right, and if we look at the screen right now, I think we just have a view of that green anemone. It's just to the right of the screen. We're just losing it, but we saw it there. I had it nice and full screen, and there we go. Our trusty RV pilot's giving us a bit better view there. Very cool. So I want to direct this question to the ROV pilot. I know we have, let me just confirm. Yeah, Corey is piloting right now. Corey, how would you describe the skill it takes to pilot the ROV? I've heard, people say it's very much like a video game, a joystick console. If you can play video games, that that's some of the skills you need for this.
Yeah, so this is the most expensive video game I've ever played. It's around $600. So I definitely grew up playing video games. Not the only skill I've acquired through life, but it's definitely a useful one. I went to school for computer science and electrical engineering. So it's many skills. Stay in school, kids, and don't forget to play video games.
All right, very cool. It's good to hear that those video game skills can transfer to some real science too. That's awesome. We have a question here live via the YouTube chat. This is from Rose. Rose is in Miss Lee's class, and Rose wants to know, what is powering Sentry and Jason? How are they staying powered so deep underwater?
So I'm going to take you over to our Sentry engineer, and I'm going to have her tell you how is Sentry staying underwater and how it's getting power.
So we have batteries. So one of the big differences between, I don't know if you have pictures that you can see of Sentry and Jason, but they look very different. One of the big differences is that Jason has this cable that goes from the robot all the way up to the surface, and Sentry doesn't have that. So, just think of anything that you have that doesn't plug into a wall, runs off batteries. We run off of giant batteries. So we charge up our batteries before we go in the water. It takes about half a day or so to charge up, and that's what we run off of. So that's really what determines how long our dives can be, because at a certain point we run out of power, and then Sentry is smart enough to say, hey, I'm low on battery, I need to come up now, I'm going to come to the surface and I need you to come get me. And we like to plan our dives so that we don't have it get to that point, so we'll tell it to come up first. But yeah, it's a great question.
All right, I'm going to bring in another one of our camera classrooms to get a question. Mr. Atkinson's group is hanging out with us, some grade 6-7s. Let me bring them in. All right, there they are. How are we doing today?
Hi. My question for you is, If the fluid pathways were to get clogged, is there anything that could cause the hydrothermal vents to explode, and could this affect the cleanness of the ocean?
Okay, so I'm just going to repeat that question just to make sure it came through. If those pathways where the materials come out of the hydrothermal vents, can those become clogged? And what kind of impact would that have? Would there be an eruption, an explosion of the vent?
Dr. Michel, you want to take this or you want me to give it a go?
If you could give it a go, because we had a really hard time hearing the question. So if you heard it and you
Understood. Understood. Well, this is Pete again. That is a great question. And the answer is this. A lot of these chimneys are not like the chimney in your house. They're not like solid rock. They're actually porous. Think of it more like a rock sponge, right? And so when those plug up, they don't really explode. They just leak out somewhere else. There are some times, though, where a chimney will sort of plug up and it could come barreling out of somewhere else. What's really exciting is sometimes we have volcanic eruptions underwater, and we really do get big explosions of rock and gas and all sorts of hot water. And they even leave big craters on the seafloor that are really, really cool looking. So yeah, that's a really cool question. There's a lot we don't know. And if you're interested as you continue to grow up, there's lots of work that could be done in that area. So good job.
All right, great question. We'll come back to that crew shortly. I'm going to go now to Miss Cannon's class. They're joining us from Olympia. They're 5th graders. Let me see if I can bring them into the call here.
Well, hello there.
Hey, 5th graders, how are we doing?
So they have a couple questions. I have a big question. We have one more coming up.
What's the temperature down there?
Oh, the temperature. What's the temperature down there?
That's a great question. So one of the things that we have on the Jason vehicle is a temperature probe, so we can actually make that measurement. The water is about 4 degrees C around them, but actually in the hot fluids, it can be very, very hot. So we made a measurement in the middle of the night, and we got over 300, and then something actually went wrong, and our temperature probe actually broke. So our guess was that it was about 350 degrees C, but it actually broke at that point. So we're going to have to fix that and go back down on our next dive and make another measurement, and hopefully not break it this time. We're not sure if we melted something because it was so hot. But that happens on these dives, is not everything always goes right, and we often have to go back down and try again. So that's a great question.
All right, very cool. Great question. 5th graders, I know you said you had a couple, so if you want to pop in another one, we'll let you go ahead.
Okay, yep, we got another one.
How long do you usually stay underwater for?
Okay, so a question about ROV Jason. How long is ROV Jason going to be spending underwater?
I can go ahead and answer that one. So on this dive, we expect to be underwater for about 24 hours. It depends how long things take. Sometimes we overestimate how much time we need, but usually we underestimate. Usually it takes us longer to do things, or we get very excited about something we see and we want to stay longer and we want to make more measurements, or we want to collect more critters. So it usually ends up taking us longer on the seafloor than we've anticipated because we get very excited about what we're seeing.
We have a note from the Jason crew over here too. Their record is just about a week, staying underwater for a week.
Wow. Very cool. What I think I'm going to do now is give our students a chance to take part in a little quiz, a little Kahoot quiz. So while you were talking earlier, I pulled together a couple questions to see how sharp the students were and how well they were paying attention. So we're going to take a little pause and let the students get interactive, and then we'll visit for a few more questions. So if you want to take part in the Kahoot quiz, I'm going to pop up the link right here for you. So Kahoot.it. Oh, that's a really cool view. I'm going to change the view over so we can get a look at the vent there. There we go. All right, really cool view there. So if you visit kahoot.it, you can find the spot where it's going to ask you for a PIN number. So if you're lucky enough to have one-to-one technology in front of you, you can join directly that way. If you're in a classroom and don't have that, then your teacher can pop it up on the front board for you and you guys can shout out your answers. So you're going to be asked right now for a Kahoot Quiz code. It should be popping up right now. I'm going to give a little share screen here. And there it is. So the code for today is going to be 5771129. So we'll give a moment here to see if we have some students, some players come and join us. There we go, coming in already. Excellent. And then we'll jump into the quiz. So I pulled 4 multiple choice questions. You have 20 seconds for each question. The faster you get the answer in, the more points you're going to get. If you put in the wrong answer really fast, well, that's not going to help you a whole lot today. We want the right answer and we want it as quick as you can. We'll just give things another couple more seconds to get some classrooms in. Then we'll jump back to our awesome views and we'll pop in some more questions. I see more questions coming into the chat, which is great. Okay, here we go. So the questions aren't too hard. We'll see how well you are listening in today. So first, which ocean basin is being explored right now? Was it the Guaymas, the Marianas, the Guam, or Tonga? What basin is being explored right now? Easy question to get us rolling. A couple more seconds. All right, Guaymas is correct. Good job. Let's check our leaderboard. YK Peyton is in the lead right now, but it's pretty close. Let's jump on to question 2. What is the nickname for the hydrothermal vents? Was it stacks? Was it chimneys? Was it towers? Or was it hills? We've got 5 more seconds to get your answer in. All right, great job, crew. By far, everybody went with chimney. No shift in that top spot of the leaderboard, but let's jump to question 3. What was the sensor Beckett was working on to detect? Was it detecting oxygen gas, nitrogen, carbon dioxide gas, or hydrogen? Who remembers what Beckett was working on when we visited his station? All right, couldn't fool this crew. Carbon dioxide is the correct answer. We've got a bunch of movement down there. And let's see how we end up with our final question. What depth is ROV Jason at right now? Was it 1,000 meters? Was it 1,800 meters? Was it 2,500? Or was it 3,000 meters? A couple more seconds. All right, by far, the majority went with 1,800 meters. Good job, everybody. Let's take a look at our final podium and see how we end up. Ain had 4 out of 4 in 3rd place. Huge had 3,600 in 2nd. And Peyton ran it tape to tape. Good job, Peyton. That was awesome. Thanks so much for playing with us in the Kahoot. Let's come back from that screen share and let's jump right back into our Q&A action. So in the chat, we've got a great question here about the worms. How big, how long are those tube worms? It's hard to judge when you're seeing it from the ROV view.
Hi, folks. Can you hear me okay?
We gotcha.
So the tube worms, when they first discovered them, they brought up tubes that were 6 feet long or about 2 meters long. And everyone thought, oh my goodness, these are 6 foot or 2 meter long tube worms. And they wrote it up in the papers and everything. I don't think that's true. Most of the tube worms are about 1 meter long or about 3 feet long, but they grow tubes that are twice as long because they can crawl up them and get higher up in the water, or it helps position them where there's the most amount of food for their symbionts.
All right, let's take a look at that view. We're getting a nice close zoom right now. There we go. You can see a squat lobster there. We can see a nice view of those worms. Very cool. And so we're seeing a little shimmer in the water as well. That must be the heat that we're seeing coming off from the chimney. All right, let's bring another classroom in here and let's grab some more questions. So Mr. Brooks' crew in New Jersey, I'll bring you back in. Do you guys have a follow-up for us?
Thank you so much. This is perfect timing because we actually have to get ready to go to lunch. I have two quick questions for you guys. One, what is the pressure down there? We're at 1,800 meters. And two, what do you guys do if somebody gets seasick on the boat for so long?
Good questions.
Great. I'm gonna have
So we
my
can
student
answer the
back there.
pressure question.
Oh, go ahead, Sarah.
So the pressure down here is about 180 atmospheres.
Can you put that into a little bit of context? How does that compare to, say, if you were on the ship, standing on the deck?
Yeah, it's 180 times what we experienced.
So it's about 180 times what we would experience just standing on the deck.
Okay. And then as we're kind of looking at the little video here, it looks like an instrument Jason's deploying right now. What are we looking at?
What's the instrument?
So you're looking at Jason's big mechanical arm at the moment. So one of the pilots is actually controlling the movement of that arm.
Okay. And so that second question, maybe Anna, someone might want to answer that from above. What's anybody having any seasick issues, and what do they do to counter that?
Yeah, so I'm going to have two of the graduate students that are here. We've got Beckett and Genevieve. This is Genevieve's first cruise, and I know she was very worried about it. Genevieve, do you want to tell us how you felt when you got on the ship?
Yeah. I was very nervous about being seasick because I sometimes get that way on normal boats. But this is such a huge boat, and we got really lucky, and the water has been just smooth as glass. And so no one's really been too seasick on the boat. We also eat a lot of ginger candies to keep our tummies feeling good, and we have some medication you can take if you feel bad. So it's been great. Great weather. We've been really lucky out here on the boat.
And Beckett, you too? You feel pretty great?
Yeah, we've been really lucky with the weather lately, so not too much rocking and rolling on the ship, which is always much easier to work in and harder to get seasick in. But I'm definitely feeling lucky because on my last cruise I definitely got a little seasick and that was uncomfortable. But always we do our best to take care of everyone when they're sick and let them rest.
So we have an update on the pressure. To put it in a way you can maybe conceptualize a little bit better. That's the 180 atmospheres is about 300 pounds on 3,000 pounds on each inch of your body. So everything we put down on Jason actually has to be pressure tested so that it can withstand that high pressure.
Very cool. Well, thank you, Mr. Brooks' crew in New Jersey. Thanks for hanging out with us today, and have a good lunch. Okay, I'm going to bring Mr. Atkinson's class back in, see if they have a follow-up question for us.
Needs to be quiet. Thank you. Dominic? Great. No, it's not.
Is there any evidence to suggest that creatures from one vent ecosystem can migrate into others? If so, could that negatively impact a different ecosystem surrounding a vent?
Great question, bud. Very cool. So just to repeat that, is there any evidence for organisms moving from one vent ecosystem to another, and can that have an impact?
We're going to send that out to Pete Gerges, who is the lead biologist on this cruise.
Hi, folks. Yeah, so organisms can move from one vent to another when they're things like fish and crabs. We think that they crawl between the different vents. Other organisms like tube worms, they put down their tubes and they can't walk anywhere. So the way they get around is by frankly just having lots of babies that go up into the water and settle on new tubes. So the parents don't move, but a lot of times their babies will go colonize a new vent. And that's how they get around down here.
All right, great question. Let's bring in our crew in Ottawa, see if they have a follow-up question for us. Miss Rob Class.
Hi there. Sorry, for some reason our camera isn't working. Hunter is here and he has a question for you.
How long does it take for the chimney to form?
How long does it take for the chimney to form? And we had a follow-up question, which was, it sounds like an expensive video game. How much does it cost? Thank you.
So the fastest growing vent can form in as little as 4 months. So really not that much time at all. And then Corey mentioned before, I think that it maybe got cut off, that it costs about $6 million. So yeah, very expensive video game. And that's just the vehicle itself.
All right. Well, I'm loving these views. This is just an amazing view from the deep. Wow, so cool. I'm going to grab another question here via YouTube. And someone tuning in is wondering, can these vents tell us anything about the origin of life on Earth?
Hey folks, it's Pete again. I love this question about origins of life. When they first discovered hydrothermal vents, they thought that maybe this is where life originated, because younger Earth had lots of these kinds of hot, oxygen-free environments. But the thing is, when we study the animals here and the microbes, they are not likely to be really ancient, at least most of them, right? Certainly true for the animals. None of the animals you see here are really, really ancient animals. They're just not. Some of the microbes maybe, but most aren't. So what we think is that life may have originated at something like these hydrothermal vents. There are some other systems that are a bit like these. They're called serpentinizing systems. Our life might have evolved in warm diffuse flows, but the data tell us that it is not probably these sites. I hope that helps.
All right, another great question. I'm going to bring in our 5th graders from Olympia and see if they have one more, a follow-up question or two for us.
All right, thank you.
I think I heard that. Was that question, what makes up the material we see coming out of the hydrothermal vent?
Yeah.
Yeah?
But the purple color that we can see?
Is that a crab?
Okay, so a few questions there. One was about, what is in those plumes? What makes up those plumes we see coming from the vent? And then I think someone also noticed some purple kind of material on the side of the chimney, and they're wondering what that might be.
We're not able to see the video down here with the Sentry group, so maybe the Jason guys who can actually see the video up there can talk about what they just saw.
Hi, folks. So what I think you're calling the purple stuff, that's a mix of iron and other sulfides. That's what makes up the base of the chimney. And someone asked about the plume. So the plume and the fluid coming out of the hydrothermal vents, it's basically very opposite to seawater. So this is full of a lot of very reducing compounds like ammonia, methane, sulfur, whereas the ocean is full of a lot of oxygenated compounds like obviously oxygen, nitrate. And so it's this mixing of the waters that creates this really cool chemistry. And the other difference, like key difference, is obviously like these hydrothermal vents are very hot fluid. Like end members can be like 300 degrees Celsius at some of the warmest. That's like 3 times the temperature to boil water. And ocean is very cold. It's 4 degrees Celsius, which is just barely above freezing.
All right. So a little more specific question here about the cruise, do undergrads get the opportunity to sail on research expeditions like this?
Sure, that's a great question. On this cruise, we don't have any undergraduates. We have quite a large group of graduate students, but sometimes there are opportunities for undergraduates to go to sea. Sometimes we have summer students that work with us that we might bring out on a cruise. Yeah, there's oftentimes there are undergraduates that are able to come out to sea.
All right. Well, it's hard to start thinking about pulling ourselves away from this view and having so many great scientists and engineers to talk to and ask questions for. How much longer will you be on this current expedition?
That's a great question. So we are at sea at this site for 12 days in total, and then we will sail. It'll take about 5 days to get back to where we started in San Diego. So we'll be getting back in early December back to San Diego. So we'll be spending Thanksgiving at sea this year.
All right. And so if students or anybody else kind of wants to follow along, what's the best way to kind of keep track of how things are going? Is there a spot to check up?
We have been posting on our lab Twitter and Instagram, showing some of the stuff there, which is CSL Lab, which is posted on both Instagram and Twitter. There's also, if you take a look at the ndsf.hui.edu website, you can learn more about the vehicles that we're using. It doesn't have anything specific about this cruise, but you can actually learn a lot more about both the Jason and the Sentry RVs. And there's also news updates there, so you can learn more about some of the science and the engineering that's going on within the facility that runs these two vehicles.
Okay. Well, I want to start off by a huge shout out to the classrooms who joined us today. Thank you for sending in so many great questions. Thank you to the camera classrooms for those great questions. Thanks for playing along with the Kahoot. And then, Anna, it's quite an amazing team that you have behind you doing the science, doing the engineering. I'm going to try to thank a whole bunch of people. Genevieve, Beckett, who else do we have here? Amanda, Sarah, Corey, Cal, Don, Brooke, Pete, Osama, Sebastian. I'm sure I'm missing some. Thank you so much for everybody on the ship and for bringing this live to classrooms today. It's so rare to get this experience, to not only see ROV Jason working in the water, learn about AUV Sentry and how it works with its program courses, and then to get a chance to ask some really cool scientists and engineers questions. And looks like we might be seeing a little sample being taken here, right? As we get close to wrapping up here. Let me zoom in on that for our crew. So Anna, maybe you can talk a little bit about this before we wrap up. The samples, it looks like they took a sample of the outer chimney, maybe some of the material. How is that going to be helpful?
Sure, actually, I'm going to pass a question on. I think that Osama or Sebastian are in the van, and one of them, I think the sample, they are collecting it to study their science. Osama or Sebastian, one of you up there?
So Osama and Sebastian have left their watch, but we're taking that sample to study any of the microbes that might be in that material. So you just saw Jason grab it with its mechanical arm and then put it in a little box, which it will bring back up to the deck of the ship.
Perfect
so you can
timing.
see here, we've kind of grabbed a bigger piece, and we'll also take this piece back up to shore.
All right, let's zoom in one more time on that as it's happening.
Okay.
Very, very cool. Well, again, perfect timing to see the sample being taken. Again, a huge crew. Shout out to all the scientists, the engineers, all the crew aboard the research vessel Revelle. Thank you so much for an amazing event today. Anna, I'm so glad we were able to do this. It seems like just yesterday we were chatting about this live event, so it is so cool to be doing it live and in real time with classrooms.
It's great. We hope that everybody learned something today, and we hope that this will inspire some of the younger students that we're watching to consider careers in ocean science, ocean robotics, ocean engineering. We'd love to see some of you out here one day.
All right. Well, good luck with the rest of the expedition. Happy Thanksgiving next week, and thanks so much for spending time with us today.
Great. Thank you, Joe.
Thank you all.